Okay, today we're going to learn about imaginary numbers. So let's take a little sidestep. You learned yesterday about the discriminant. And based on what you learned yesterday, you look at this and you see that this is a parabola that doesn't cross the x-axis. That means when I do the discriminant of b squared minus 4ac, I will get an answer that's less than 0. All right, so I'm going to do a little pre-calculus right now. I know this is a parabola, and I know mama is of the equation y equals x squared. And she gave birth, come on, let's move that, there it goes. And she gave birth to this parabola right here. So let's figure out the equation of this parabola. Okay, mama starts at 0, 0, and then her turning point went over here, and then it went up there. So what's the equation of this parabola? Well, y equals, there was an x shift of 2, and since it was in the positive direction, it's minus 2. We always do the opposite. And then it had a vertical shift of plus 9. All right, give me 2 seconds. Let's figure that out. Square the first. My pen is acting up. Why is it not writing? Let's erase that, sorry. Try this again. X squared. Multiply in doubles, that's minus 4x. Square the last. So this is the equation y equals x squared minus 4x plus 13. Now I don't expect you to, why is this? My pen, sorry people, is not working. I don't expect you to do this conversion. That's something we'll spend a lot of time with in pre-calculus. Maybe IB Math does it, not sure. So, there it is. Now, if I go back and I solve this using my quadratic formula, negative b plus or minus the square root b squared minus 4ac. I really don't know what's going on with my pen. All over 2a. All right, so let's start substituting in. Negative b plus or minus the square root of b squared minus 4 times a times c all over double the a value. So that's 4 plus or minus the square root of 16 minus 52, and there is my discriminant. Look at that. My discriminant in this problem ended up being negative 36. Hey, that's what we predicted up here. Right up here we knew the discriminant would be less than 0 because the roots don't cross the x-axis. Okay, we get that. So we have to learn how to work with that. So the question is, what is the square root of negative 1? You see, mathematicians said this. Let's work with that. They said, say we have that square root of negative 36. Well, the mathematician said we could factor that down into the square root of 36 times the square root of a negative 1. The square root of 36 is 6, but here's the problem. You can't take the square root of negative 1. And Jack agrees. He doesn't know what the square root of negative 1 is. But our friend here, Gauss, he invented what the square root of negative 1 is. And this guy is Carl Friedrich Gauss. That, my friends, is going to be a question you should know. All right, so Gauss said this. Let's get rid of these guys. Thanks, guys. You're welcome. I don't know how to say you're welcome in German because that's what Gauss was. So anyway, Dankeschön. Hey, just came to mind. So Gauss said this. If he could define what the square root of -1 was, he'd be in great shape. Now, we know the square root of -1 is not 1, because 1 times 1 would get me 1. And we know the square root of -1 is not -1, because what times what? -1 times -1 would get me a +1, and that doesn't work. And it can't be two different answers. So Gauss said this. He was going to let the square root of -1 equal I for imaginary. Now that's a script I. And you write a script I so it stands out differently. So Gauss then said, let me take this a step further. This is where you'd want to pause the video and write this down. This is called the imaginary clock. So right now, pause the video and write this all down. Okay. The clock makes sense because when you invent something new in math, it still has to apply to all your old rules. So Gauss said this. If he takes the new number he invented, which is I, and he raises it to the 0 power, it has to be 1, because anything to the 0 power is 1. Another rule is if you take anything and raise it to the first power, you get that number back. So I squared is going to be a -1. And this is why. Gauss said this. Well, the square root of a -1 really is -1 raised to the 1/2 power. Because you're going to learn later on power over root. You may have already learned that in Algebra 1. So when I square something, it means to take 2 of them. So if I take the square root of -1 and times it by the square root of -1, Gauss said that's -1 raised to the 1/2 power times -1 raised to the 1/2 power. And if you remember, when you multiply, you add powers together. So that is, come on, pen, keep up, -1, 1/2 plus 1/2 is 1. So I squared is -1. Now, you don't have to remember all this fancy math behind this, but you do have to remember this clock. And then I cubed is really I times I times I. All right, and so I times I is I squared, but according to my clock, I squared is -1 times this third I, and that's why I cubed is -I. And what I like about the clock is it looks like a graph. If I were to make a little set of axes here, it kind of makes sense. This is +1, this is -1, this is +I, this is -I. So as long as you remember these right here, the clock is really easy to figure out. Let's say you had to do this on a test and you didn't have the clock. Well, you know it's a clock. So you would just say, okay, I know I to the 0 power is 1, and I know anything to the first power is itself. Oh, and then opposite this would be -1, And then opposite I would be negative I. So this would be I squared. Really, my pen is so not working today. I don't know what's wrong with it. This would be I squared. And then this would be I cubed. All right, so it's really simple. Let's go to the next page. Like I said, don't know why my pen is not working. There we go. So I put my clock up here, and this is what you do. The square root of negative 36. What you think in your brain is, I'm going to pull out the negative, so I factor out a negative 1, and now I just do it, okay? The square root of 36 is 6, and Gauss decided that the square root of a negative 1, he's going to let it be the letter I. So your answer is 6i, because we always write the coefficient first, followed by the variable. Negative 500. Factor out the negative 1, and then there's 500. Okay, so the square root of negative 1 is I, but remember, you still have to apply all your other math laws. So you have to continue this by saying 500 breaks down into 105. So the square root of 100 is 10. I, and then radical 5. And the reason we don't write it like this is because if you put the I afterwards, we're not sure, do you mean 10 radical 5 with the I underneath, or do you mean 10 radical 5 and the I outside? So we make sure of it by putting the I nowhere near the radical. All right, this one, we've got a negative out front here, so let's not lose that. This negative inside we factor out as a negative 1, and then we have the square root of 51. Okay, negative, the square root of negative 1 is I, and I can't break down 51 anymore. There's no perfect square that goes in it. So that's your answer. So hopefully by now you see the trick is just ignore the radical. Ignore the negative. This is what I do. The square root of 100 is 10, and since there was a negative underneath, that means it has to be imaginary, so I just whack down an I. The square root of 81 is 9, and since there's a negative under the radical, it must mean it was an imaginary number. So 10 imaginary numbers plus 9 imaginary numbers give me a total of 19 imaginary numbers. And the last type of example we're going to do is the clock. So I to the 8th. Well, there is no I to the 8th up here, but this is a clock, and it goes round and round. So 3, I to the 8th is 1, 2, 3, 4, 5, 6, 7, 8. I to the 8th is the same as I to the 0 power. And then I to the 0 power is 1. So 3 times I to the 8th is really 3. All right, I to the 99th. Oh my gosh, I'm not going to sit here and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That just takes too long. Hopefully what you saw was this clock is a base 4. In other words, there's only 4 things in it. So if I noticed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This up here is always a multiple of 4. So I could keep going right here. I just could go 20, 24, 28, 32, till I got to 99. But I'm going to do this. I'm going to take 4 and divide it into 99. 4 goes into 99 24 times, with 3 left over. So that means that's my answer. So this is really 5 times I to the third, and I to the third is really negative I. Now, how did that happen? Well, if I realize that this is multiples of 4 up here, this would have been 96, because 4 goes into 96 24 times. Then this would have been 97, 98, 99, and that would have been 100 if I kept going around the clock. Okay. Last one. I to the I, that's good. Sorry, I to the first. I squared is negative 1. I cubed is negative I. And I to the fourth, well, let's see, 1, 2, 3, 4. Oh, that's good. I have no viruses. And I to the fourth is the same as I to the 0, so that's 1. So if I added this all together, an I and a negative I cancel out, a negative 1 and 1 cancel out, that turned out to be 0. Okay, here's a little comic strip from my favorite comic strip, which was Calvin and Hobbes, which is no longer written, but enjoy. See, Hobbes is Calvin's stuffed tiger, and he believes that he's real and he talks to him. Much like me, I talk to myself.